PWM info. On the bottom side, do you see the 6 A0 to A5 pins? Those are the analog in pins. So if you're trying to read like an analog value, in this Arduino's case, between 0 and 5 volts, you plug it in there and then figure out like, okay, voltage is 3.3. If it's out of 0 to 5, I'll just pick a value between the minimum and the maximum that corresponds to that. Most of these microcontrollers will be linear as well as ADCs. You'll find some weird cases where like the transform isn't as linear. So if you get a problem with that, remember that tip. Other stuff is like there's ground, there's power, there's AREF. It's all specific. It's all like if you worked a little bit of electrical engineering, that's stuff to be comfortable with. But at the end of the day, the main parts are really just the 3.3 to the 5 volt and the grounds. Basically, just ways for you to power everything that's connected. So, I guess I might as well just jump to it. So, quick and dirty algorithm for like doing this Maraca thing. The ADC has like these 3 lines, X, Y, and Z. No, not the ADC. The accelerometer has these 3 lines, X, Y, and Z. They basically push out this analog value between 0 and 3.3 volts at some voltage that corresponds to how much acceleration there is. So, like right in the middle, at 1.8, there's like that's basically no acceleration, supposedly. It's not necessarily true, depending on the accelerometer you get. And anything higher than that means positive acceleration in that direction. Anything lower, negative acceleration. In terms of like, so there's 3 of those lines. It also takes a power and a ground. I showed it to you guys, but it's pretty small. What's up?
You say negative acceleration. Do you mean
acceleration in the basically in the
deceleration or acceleration in the opposite direction?
Deceleration is acceleration. Yeah, acceleration in the opposite direction. Yeah, that's really what it is.
Like
yeah.
Clockwise or counterclockwise.
Yeah, because it's like it's a Cartesian axis, right? So like x, well, let's say x, y, z. You'll basically just negative x, negative y, negative z. Yeah. Yeah. So that's what buzzers. These buzzers that we have, they're basically if you hook them up to power, they'll make this very noisy sound. I was a little worried that like you guys wouldn't hear them, so I put 4 of them on here. So it'll be really bad for me, I guess, when they turn on. Yeah. So I guess like quick and dirty value. There's actually one bug in here, software-wise. Depending, can you guys that basically what I told you about the accelerometers, basically positive side of acceleration, negative side of acceleration. What's wrong with this? Quick and dirty algorithm. Ooh. That's actually not the bug specifically, but it's part of it, yeah. Come on, we're all hackers. This is a software problem. It's not even a software problem. It's, I wrote this like last night, and I thought it'd work, and then I ran, and it's like, oh wait, that's stupid.
So they don't cancel each other out?
Not quite. I mean, that's not really the thing. So like the values, so like the middle value is supposed to be like, say like maximum value is 1023, 0. Middle value is supposed to be 511, right? So if you're getting all 511s, what's happening here? If you're getting no acceleration. No, that's the funny thing. It buzzes still. This is where I screwed up. 511s, like add 3 511s up, you get something in the range of like 2 buzzers buzzing. So I was like, oh wait, this is all screwed up. All right. But yeah, I mean, I'll be honest. When it comes to like working with Arduino stuff, unless you're going into electrical circuits, it's very similar to just what you were doing in software engineering. It's more, you basically just jump in. If you have an issue, just debug it on that side. If you're going special circuits, make sure those work beforehand before you hook it up to your microcontroller, at least at the basic level. So, 2 like little quick little like code examples. These are really these are like code examples that are within the Arduino IDE itself. It's provided. So what I like to do, or rather what I used to do, is that I basically would just open these up, read them, figure out how it's done, and then just copy code over to like whatever I wanted it to do. So I mean, in terms of like the blink. In terms of blink here, there's digital out runs from 0 to 13. So in this case, it's basically, all right, let's set LED equal 13. Let's set LED equal let's set pin 13 over to an output. And then over time, let's set it high, then low, then high, then low, and so on, and so on, and so on. But I mean, that's pretty useful because it shows you how to like set basically a pin high and low. And like in our case, with buzzers, we turn them on by setting them high, we turn them off by setting them low. Pretty basic stuff, and like that's, in terms of I/O, there's only a few basic operations. That's like, that one's probably gonna be like 30% of all the things you do right there. Analog again, on the other side. What's happening here, we're setting a sensor pin over to like A0, where we don't really need to set that to anything. What we need to do in order to read the value from like the 0 of A0 is to just do analog read. In this case A0, set that to the value, and you read it. Pretty easy to do. It will give you a value in this case between 0 and 1024, at least for this guy. This one's got a 10-bit ADC, so 2 to 10, 1024 values. Okay. So, that's good. Did that come up properly? No, but it's all small. All right, so let's jump in. Whoa. Would anyone like to come up here and give it a shot? Oh, we got one guy. See, I actually didn't expect anyone, so I just wrote it over here. Go for it. You got like, dude, you already know this stuff. What the hell are you doing up here?
Nobody else wants to.
All right, go for it. I mean, it's pretty easy enough.
What am I doing?
Oh, I mean, code, man.
Oh, I can write it?
Yeah. You know this is live stream.
I thought you did.
No, it's all good. I'm just gonna throw this up. Yeah, I'm just gonna upload it. Oh, that's awkward. Did I even plug this in?
This guy doesn't know what he's doing.
Shut up. I didn't power it on. So there's a switch, right? So I had it off. Yeah. Yeah, I'm waiting for it to come up. Let's see. There we go. There we go. Now it should be good. You gotta be kidding. Oh, did I accidentally put up. Yeah, sorry guys. Line 40. If you can see it, oh, I should probably take this out. Boom. Alright. Oh, that's kind of annoying. Oh, this was working earlier. Alright, let's do a little debugging, I guess. Okay, so let's just jump it up to that. That's cool. There we go. So, really, I should have just called this the medicine ball. But yeah, like that's pretty much it. I was gonna say that it's funny because I was gonna say that the next slide here. Oh shoot! Shut up. So the next slide, funny thing, was that, you know, it's easy but it counts. Since none of you guys actually did it, this doesn't count. But I'll just post the code online. It's like pretty straightforward. In terms of like all I did was that, whoops, my bad. All it did was basically just read in the values, center them, depending on what the center them, and then just, you know, if it passes a certain threshold, it just basically buzzes. Yeah, pretty easy build. In terms of like other stuff, like Arduino's one of the many things that like we've got here at PennApps. Generally, it's split between microcontrollers and microcomputers. Microcontrollers, they run some sort of real-time operating system. Basically means that like you have like something that you run code as setup, and then you just run code in a loop, just over and 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 over again. It's really meant for more like interrupts, hardware interrupts, and timers. More low level. The Arduino Leonardo, I can't say this one. Thank you. And the Uno, the Mbed, Freedom Boards, Trinket Pro, Spark Core, and Tessel. These are all RTOS. These are all like microcontrollers that like you can go check out. The microcomputers, they run some sort of Linux. They're more or less like more flexible compute platforms, depending on what you want to do. They're essentially just small computers because they're running like an OS. That's not more or less a full-featured OS. The Edison, Arduino Uno, which is more of a hybrid system because it has like something else, as well as the Raspberry Pi are all microcomputers. What's up?
Will this PowerPoint be online anywhere?
I should probably tweet it out and throw all the code up in a gist.
Yeah.
There we go. So like, I've got my Twitter at the end, so like just annoy me on that if I haven't done it. Alright, so like not all embedded platforms need to be programmed in C, especially microcomputers. Like Python, Node, Tessel's a microcontroller that you can program in Node. Tessel you can program through Node, Edison's both, Python, Arduino, Node, all is cool. Union's the same. Union's you can pretty much do whatever you want in it. Raspberry Pi, Python, Node, I mean, but that one's the one that's running a debian system, so it's close to what you're used to as like a regular computer. So RAP, obvious advice. So it's like, if you're working with hardware for the first time, it's really like learning code for the first time. And like that experience, if I remember right, wasn't too hot for most of us. Like, you know, just be comfortable being a noob, don't be afraid to ask stupid questions. Trust me, they're stupid, we know, but you're learning, so it's all good. It's like, if you're asking it like maybe 4 or 5 times, then maybe we get a little annoyed. Don't be annoyed when you make mistakes, because they're gonna happen. Even, like, honestly, it happens to us, like you saw just what happened there. Be methodical when you're debugging, stay calm when debugging. It's really easy to accidentally break something, like hardware-wise, and then you're like, oh shoot, I shouldn't have done that. Definitely set like a minimally viable product and add on to that, like after you've hit that point. Because like a lot of stuff with hardware, remember when they were teaching you test-driven development in like your college courses, and you really, and like you're like, screw that. It's like, it wastes time. I'm good at this. I can just code whatever the heck I want. I was like that. But yeah, it doesn't work all that well in hardware. You screw something up, you've got these bits of wires, like, shoot, what's screwed up? I don't know. It's gonna be a long night. Set reasonable goals. Google's your best friend. DuckDuckGo's cool too. I don't really use Bing that much, but I hear it's cool too. Like in terms of stuff to look at, I've showed you like a little bit of the analog image GPIO, just like briefly. Haven't really touched about most of the stuff out there. There's hardware communication channels, mostly like UART, SPI, I2C. A lot of sensors are connected through these buses, and a lot of like device-to-device communication is done through this stuff. Software-generated communication channels. So if you see like software serial in the Arduino libraries, that's basically just a bit banged out protocol that's like done software-wise. It's actually really cool. Wireless communication through Bluetooth, Wi-Fi, XBee, and other like 2.5 gigahertz radios. A lot of like these drones that you see that are like running on these 2.5 like basically a lot of the big drones will run on 2.5 gigahertz radio. So like hacking drones by like basically having your own like 2.5 gigahertz like transmitter, so much fun, so much fun. Remote cars are usually the same. Smaller stuff not so much because it's like that's like infrared, and then they have their own thing. There's like different logic voltages, 1.8, 3.3, 5.0. You can't just plug one thing that's designed to work at one logic level into another thing. You'll have to use like level converters, just something to just keep track of. Because when you get like say an Arduino and like this, if you get like an Arduino like an old school one, and this accelerometer won't work instantly because this guy demands 3.5 and that one works on 5.0. There's digital analog converters. If you want to output true analog signals, analog digital converters, the analog to digital converters, how to analog inputs actually. Actual electrical circuits, I didn't touch a bit of that. Have fun with that stuff. And like, just, how to pick up and use hardware sensors. It's like all, Yeah, there's a lot of stuff out there, but I mean, trust me, it's fun. It's like, first you learn how to code, then you learn like what are the cool, like a few different languages, then you like start thinking in libraries. But like once you get like the basics, switching between like say languages or like libraries actually isn't all that bad. It's the same for hardware at the end of the day. All right, so if you guys have questions now, I guess I'll take them. But I mean, later chat about hardware. I'm Stephen Crossing on Twitter, and I'll be outside 100 at the Mastery Intel table all night and tomorrow. I go to school here too, so you can find me. You guys got questions? Quiet crowd. Yeah. We love you, Steven! Oh, okay. What's up?
Can you use different languages with Arduino, like C, Java, and Python?
It's a bit tricky because like Arduino itself is Arduino, like these low-level microcontrollers. They're basically meant. They have like basically a tiny operating system that you basically can't load all that stuff easily on. Totally. I'm trying not to be biased because we didn't actually sponsor this tech talk. But like on Edison, I mean, you can get like a node server communicating with like a Python script that's just communicating with through like a socket onto your Arduino. I'm sure you can do the same. You can do the same with like Raspberry Pi, and I'm pretty sure you can do the same with you. Like microcomputers give you a lot of flexibility. They can be a bit of a pain in the ass to start with because like there's a few more things to like learn about them, but like it's a joy to work with them.
With the Edison, or really with any of these tips for how to connect just generally electrical devices to them, and also how do we get our hands on around here?
Oh yeah, so so like hardware checkout, second floor over that way. Like they've got a bunch of stuff. Like everything I mentioned over here actually, somewhere around here. Yeah, everything I mentioned over here, all these devices, they're available for checkout to like use. In terms of like hooking up general things, I'll be honest with you, it's not very intuitive the first few times. And it's just not. It takes a few times to get used to. Like hit me up, hit another hardware mentor up. The best way of like passing this information on is just have someone like, just work with something for a bit. Because like you could be banging your head against like stuff for like a few hours, but this is like, you're at the point where it's like, this is genuinely easy stuff. We can teach it to you in just a few seconds. Yeah. Anything else? Should we end this? Boom, I'm gone. See you guys. Oh, yo. That's the Twitter link. I'm gonna post this all up in I'll post it, go to the gist. I'll like tweet out a link to that. Yeah, no, that's
Oh, I remember. Yeah, I remember. tasted really good, but like,
So like I've got I set up this like rail.
Did they come from?
So anything connected to that. So the way these buzzers work, we set this high. So you set this high.
Average is right up here.
So the way I've got it here is like, these are all like.
Paths and so we don't solve any of that.
And the nice thing about
One of the passes was one. I forget which one. Because it was pretty rough. I had this last one.
rather than high value.
It's
I guess that's it.
yeah.
That's the way.
I voted for probably nowhere near enough, but try.
Who do they have on there? Oh.
Actually.
But then we were hard again. I guess this one. You stay for like a full time. I should probably.